Hi everyone. In this video, we are going to learn how to sketch the graph of a linear function and hence determine the domain and the range. So here I got 10 examples in a linear of a linear function, and I'm going to start to discuss the B first because the B, the domain, is just all the real number. I'm going to discuss this example and then followed by the C. Then I will continue with the example A and the following question. So here we look at the function 2x plus 4. How are we going to sketch the 2x plus 4? Here I have my x-axis and y-axis. To sketch the 2x plus 4, I will going to start from the basic graph, that is y equals to x. Y equals to x is the basic graph of the linear function. I'm going to start the y equals to x. After that, from the y equals to x, we are going to sketch the graph of y equals to 2x. From the y equals to x, I'm going to sketch y equals to 2x later on because my function is 2x plus 4. After we have a sketch y equals to 2x, I'm going to sketch the graph of y equals to 2x plus 4. Alright, we start from the y equals to x first. This is a graph of a y equals to x, where this is a linear line passes through the origin 0 0. Okay, now from the y equals to 2x, I want to sketch the graph of y equals to 2x. Okay, you can see that the gradient is increased from 1 here into 2, meaning that y equals to 2x will be more steep, or we say steeper than the y equals to x. We should sketch a graph, a linear line, which is steeper than y equals to x. The graph of y equals to 2x will be some sort like this, and it is also passes through the origin, just the gradient is higher compared to the y equals to x. After we have sketched y equals to 2x, we can erase the y equals to x, leave the y equals to 2x. Now consider the y equals to 2x to sketch the y equals to 2x plus 4. From the y equals to 2x, we are going to increase, or we're going to move our graph of y equals to 2x 4 units upwards. All right, because here we got a plus 4, right? 2x plus 4, meaning that later on I'm going to move my graph y equals to 2x going up for 4 units. Yeah, 4 units. So the graph will be like this. Now you can see I got a red line here. I will label this as a y equals to 2x plus 4. And what you can see is my graph of y equals to 2x plus 4 is actually parallel to the green line, to the green graph, which is y equals to 2x. But the location has changed. How do I change my location? I just move this point, 0 0, move upwards for 4 units. So from the 0 0, it will become 0 4 into here. And now this graph having the x-intercept as well, you need to find out this value. Now I would just erase the y equals to 2x. Finding the value of the x-intercept, we just substitute y equals to 0. You have a 2x plus 4 equals to 0. From here, you solve it. You have a x equals to negative 2, meaning that this value, the x-intercept, will be x equals to negative 2. Now, since the question or the function did not restrict the domain, meaning that we can actually put an arrowhead over the endpoint to show that our graph is going to the right, okay, indefinitely, and going to the left indefinitely. At the same time, it also going up and going down indefinitely. Okay, so this is our graph. To find the domain now, my domain is a D. You can use a symbol D, stand for the domain of F. D of F is equals to, so to find a domain, I'm going to look at my graph and find a point which is the most to the left. Okay, look at the red line, the red graph here. What is the point going to the left, the most close to the left? This is the one. Okay, I will highlight with my the green circle here. This is the endpoint which is the most close to the left side. So in order to get the domain, I'm going to find what is the value of x that can represent this point. Since this endpoint going to the left indefinitely, so the negative infinity will represent is x coordinate. X coordinate. Just use a negative infinity to represent the x coordinate, because since this graph don't have any endpoint over here, so we use a negative infinity to represent its x. All right, x coordinate. And after that, in order to find the highest point of the domain, all right, we will find a point which is close to the most closest to the right. The closest to the right is this point. This is the endpoint which is I can see from my graph, which is closest to the right side. Okay, so from this point, I will try to find a value of x that can represent this endpoint. What is the x coordinate? You can ask yourself, what is the x coordinate of this endpoint? So since this endpoint is going to the right indefinitely, non-stop, we can say that infinity will be the best to represent the x coordinate of this endpoint. So as a conclusion, the domain will be from negative infinity to infinity, or some people, they would like to write their domain in the set form. You can always write your domain as x is all the element of the real number. Okay, so this can be the answer as well. Now we proceed to the range of the f. The range of the f, we will refer to the value of y. To get the range, I'm going to find from my graph the lowest point of my graph. All right, look at our graph. The lowest point will be here. This is the lowest point. I highlight with the green circle. Okay, this endpoint, I will say that it can represent the lowest point of the graph. So now, in order to get the range, I'm going to find the y value of this point. What is the y value, or we say y coordinate of this point? So since this point, you can see that the endpoint is complete with the arrowhead, meaning that this point is actually, this end point is going downwards without stopping. Okay, non-stop, indefinitely, going down, just going down. So what is the best value that can represent the y coordinate? I will use the negative infinity. Negative infinity is the best value, which anyhow we don't know what is a negative infinity, but since this is going down non-stop, we use a negative infinity to represent its y value. So means that our range will start from negative infinity, and followed by the endpoint of the range, we will search for the highest point of the graph. This is the highest point of the graph. All right, highest point of the graph, again, you can see the arrowhead here, means that this graph is going upwards without stop, okay, non-stop. So what is the value of y of this endpoint? The best can represent the y value of this endpoint is infinity. So again, the range is from negative infinity to infinity, or some of you may prefer to write your range in the set form. You can always write your range in the set form like this. Y is the element of all the real number. So remember that if you want to write your answer, domain and range in the set form, there will be some difference between them. That is the symbol for the domain, you will use x, and the variable for the range, you will take the y. You don't use both x. That is incorrect, because the range, we will refer to the y value. For your information, if any linear function, if the linear function without any special condition or any restriction of the domain and the range will always a real number. Is from negative infinity to infinity. The same for the range. Okay, so the same example, okay, the same thing will happen to this function. We need to sketch this graph, and later on we need to determine its domain and range. Without sketching the graph, we can predict that the graph, the domain is all the real number because it's written over here. And if the domain is all the real number, then the range is supposed to be all the real number as well. Okay, unless the function here, it will attach with a special condition. They restrict the domain. If the question restrict the domain, meaning that you need to slightly modify the domain and the range. First, you prepare with your axis, x-axis and y-axis. And we start from our basic function, okay, that is y equals to x. From the y equals to x, I'm going to sketch a negative x first, okay, just close this 1 over 3 up. We just focus on y equals to negative x. Now we want to sketch the y equals to negative x. All right. From the y equals to x, want to sketch a y equals to negative x, actually is the reflection about the x-axis. Okay, so y equals to x reflects about the x-axis. You will have this blue graph. All right, as if that this point reflect about the x-axis, it will be reaching here, and this point reflect about the x-axis, it will be on top of the x-axis, and the origin reflect about the x-axis still will be at the x-axis because the x-axis as the mirror of the reflection. Okay, so now you can erase this off, left the y equals to negative x. From the y equals to negative x, I'm going to sketch the graph of y equals to negative x plus 1 over 3 because the function just given here is a plus 1 over 3. Plus 1 over 3, from the graph of y equals to negative x, I'm going to move my graph of negative x, move up for 1 over 3 units. So it will become like this. So the red one, the graph with the red color, okay, is the y equals to negative x plus 1 over 3. So the blue, okay, you can see that the red line and the blue line is actually parallel to each other, okay, but they are having the translation. The location will be different, and this y-intercept become 1 over 3, and now we can erase this off. Okay, so this is a graph of negative x plus 1 over 3, and now you can see that it intersect the x-axis. You need to find out what is the x-intercept by substituting y equals to 0. And you have a negative x equals to negative 1 over 3, x equals to 1 over 3. This point is also having the value 1 over 3. Okay, so since the x taking the domain is taking all the real number, you can have the arrowhead over the endpoint to show that the graph is going to the left and right indefinitely and up and down indefinitely. Okay, so since the question did not restrict the domain, again, the domain for the function is negative infinity to positive infinity, or you may write in this form, that is a set form, x is all the real number, and the range also from negative infinity up to infinity, okay, or you say that y is all the real number. Okay, so the method is just the same as the example on the first example just now. Okay, we find the highest point, the point which is closer to the left and closest to the right to get the domain, and to get the range, we find the point which is the lowest point, okay, and determine the value of y, and find the highest point and get the value of y, okay, and then that will be our range. All right, moving to the third example, we have fx equals to negative 10x, and you can see that there is an interval written over here. This means that this is the domain that requested by the question, okay, by the function. We only want the domain from the 0 to 5. So just ignore the domain first. I will try to sketch the y equals to negative 10x. Always I will start from the y equals to x, that is the basic graph. All right, the basic graph, that is y equals to x. From the y equals to x, I'm going to sketch a y equals to 10x. Yeah, I'm going to sketch a y equals to 10x, which I will compare the gradient. The 10 is much more higher than 1, meaning that the y equals to 10x is the graph which is very steep compared to the y equals to x. Now I will try to sketch a line which is steeper, much more steeper than the y equals to x. I represent this line with the y equals to 10x. After that, we erase this off. Then now we proceed to negative 10x. From the y equals to the 10x, I try to sketch for the negative 10x, meaning that now from the positive of the 10x, I'm going to multiply all by -1, become -10x, meaning that this graph is going to be reflect about the x-axis. The x-axis is playing the role as a mirror, and the graph will be reflected about the x-axis. This point will become something somewhere over here, and this point when reflect about the x-axis will become somewhere over here. So the graph will be like, can see now I represent this red straight line to as a -10x. Y equals to -10x, then erase this off. You got this. Okay, so this graph, you can see that originally we are actually having this graph where the 2 endpoint is actually going down and going up indefinitely. But now I just want the domain start from the 0 to 5. So here is the point of 0, and the 5 is maybe, okay, I will say that this is a 5, okay, because this is a graph, is very steep, okay. So I will take this as a 5. We project one dash line into the graph. Okay, then we cut the graph. Okay, cut the graph by using the dent circle. Okay, dent circle, as if the dent circle is your scissors. You cut the graph. And actually down here we have the graph, okay, we have the graph, but we cut the graph into 2 parts. That is, the first part is over here before the 5, and the second part is after the x equals to 5. All right, then refer to the graph, okay, refer to the domain here. We want the 0 to 5, right? So the 0 needs to cut it by using the dent circle. Why I'm using the dent circle? Because both of the 0 and 5, okay, both value is included, because here is a close bracket. This bracket means that it include the value of 0, and the x also include the value of the 5. So I'm using the dent circle to cut it into the 3 parts: the first part, second part, and the third part. All right. Refer to the domain given. They just want to remain the graph from 0 to 5, in between 0 and 5. So the rest, we can just erase it off. Okay. So I use a purple line to represent the graph that we want to remain. Okay. Including is a dent circle. And the rest of it, I will just erase off. Okay. Okay. This is the excess one. So our graph end up, we have a 0 to 5, okay, x from 0 to 5, and the y value, you need to find it out. The corresponding y value when x equals to 5, what is the y? When x equals to 5, the y is -50. Just substitute into the function, x equals to 5, y equals to -10 multiplied by 5, that is -50. Okay, so you have the graph. You can label this as a y equals to fx. From the graph, I want to determine my domain of f. Okay, from the graph, you find a point which is closest to the left. Closest to the left, this is the point which is closest to the left. And you can tell the value of x of this point, that is 0. And finding the point which is closest to the right, this is the point which is closest to the right. Okay, the x value is 5. Okay, we want to get the domain. When we want to get the domain, we always refer to the x value. For this point, the x value is 5. So the domain end by the 5. Okay, ended by 5. And if you want to write this interval or domain into the set form, this is the one: x is greater or equals to 0 and less than or equals to 5. And you put the x, okay, double dot here, and close it with the set, okay, the bracket of the set. After that, to get the range, the same thing, I will try, just now for the range, we're finding the point closest to the left and closest to the right, right? And finding out is x value. Now, for the range, I'm trying to find a point which is the lowest point and the highest point of my graph. The lowest point is this point. This point is the lowest point. And the y value is -50. For this lowest point, the y value is -50. So my range will start from -50, and this is a closed bracket because it is include the -50. You can see from this dent circle. And the highest point for my graph is this point. What is the value? What is the y value for this point? That is 0. Okay, because this is the origin, the y for this point is also 0. So the range will be from -50 to 0, and is include -50 and 0. You also can write your range in the set form, that is start with the bracket and the y double dot. The y is start from -50. We can say that it's greater or equals to -50, less than or equals to 0. Just close with the bracket. This is the answer. For this function, I'm going to sketch a graph, -x minus 4, and the domain is from -10 to 10. Just ignore the domain first. Just now we start to sketch the graph for y equals to -x minus 4. I will always start my graph from my basic graph, that is y equals to x. This is the graph representing y equals to x. From the y equals to x, I'm trying to sketch the graph of y equals to -x. When you negative the x, okay, meaning that the y is has been multiplied by a negative, the graph of the y equals to x will be reflected about the x-axis. So you will get this. I will use this purple line to represent the reflection of the y equals to x. Then this equation will become y equals to -x. Erase this, erase the y equals to x. All right. Then you have y equals to -x. From the y equals to -x, I'm trying to sketch a y equals to -x minus 4. Meaning that now the -x, the graph of the second graph here, will be moved down for 4 units to produce a -x minus 4. So you will have, I use this red line to represent my y equals to -x minus 4. Erase this off. Okay, so we have sketched the graph of y equals to -x minus 4, where the y-intercept is -4, and you would like to know the x-intercept. You always can substitute the y equals to 0 to get the x. Substitute y equals to 0, solve it, you will have x equals to -4. So the x-intercept also -4. Now, after we have completed our graph, I will start to consider the domain that is given. This is a special condition because the function just want to remain from -10 to 10. X is from -10 to 10. Okay. So you can, because of we are actually sketching, we don't have to be too accurate. Okay, just need to make sense. Okay, so this is as if that this is a -10. From a -10, I use my scissors. Okay, I will say that my dance circle will be my scissors. Cuts the graph, -10, and then until 10. All right, until the 10. So as if that this is your 10. X equals to 10, and use the dance circle to cut your graph. So our graph, we just want from a -10 to 10, right? So this is our graph. Okay, this is our graph. The red line representing our graph, we can label our graph as a y equals to fx. From here, we can determine our domain. Okay, to get our domain, we find the point which is closest to the left. Okay, this is the point which is closest to the left, and its x value is -10. So the domain is start from -10 until a point which is closest to the right. This is the point which is closest to the right, and its x value is 10. So we just write down this is 10. Or you may perform your answer in the set form, that is -10. X is in between -10 and 10 and include both value, and x double dot, close it with the set. Okay, after that, to get the range, we find the lowest value. This is the lowest value of the graph, and the y, the corresponding y, we need to find it out. Okay, so we need to find the corresponding value of the y. We need to find this value. So in order to find the y value so that we can get our range, I'm going to build this box, this table. Find out the corresponding of value of y for the value of for the x -10 and 10. After I have substituted the -10 into the equation, into the function, I got my y equals to 6, and that when the x equals to 10, y equals to -14. So this value is -14. This point having the y -14, and the highest point having the y equals to 6. Having the y equals to 6. From here, we can get our range. The range is finding the lowest point of the graph. This is the lowest point of the graph, and its corresponding value of y is negative 14, right? So just put negative 14 as our beginning point of our interval for the range. And it ends up with the highest point. Highest point is over here, and its corresponding value of y is 6, right? So this interval will be end up by 6. And both using the close bracket. Why we use close bracket? Because both of the point and point, we can see that we are using the then circle to end the point. Okay, or you may write your range in this set form, that is y is greater or equals to negative 14, less than or equals to 6. Close it with the bracket, just like that. For this example, I'm going to sketch a y equals to x first, and then followed by y equals to x plus 1. After this, I will try to cut my graph into follow the domain that is from negative 1 to 3. Remain the negative 1 to 3. The rest we will erase off. So now we start with our basic graph. As if this is our basic graph, y equals to x. From the y equals to x, I'm going to move up my graph 1 unit. To sketch the graph of y equals to x plus 1, I'm going to move up my graph of the y equals to x, go upwards for 1 unit. From this origin, 0, 0, I move up 1 unit, so the y-intercept will become 0, 1. This red line represents the y equals to x plus 1. And this y-intercept will be 1. And the basic graph, you can just erase this off. Okay, after that, you would like to find this value as well, the value of the x-intercept. So to get the x-intercept, substitute the y equals to 0. You got your x equals to negative 1. This value is negative 1. The x-intercept is negative 1. After you have completed your graph of y equals to x plus 1, we've done it. Now we want to consider the domain that is required by the question. The question just wants the domain from negative 1 to 3. So we use our then circle. Okay, I will use that as if that my then circle is my scissors. I cut the graph at the negative 1 and then up to 3. So the 3, you try to measure it. Okay, estimate your 3 somewhere over here. And cut your graph by using the then circle also, because here you see the sign here is include 3 and include negative 1. There's an equal sign over here. So I'm using the then circle. After that, connect the point. I will connect the 2 points, okay, the 2 then circles by using this blue line. So means that I will erase off the excess graph, the excess graph. So here we can see that my graph just appear from negative 1, x negative 1 to x equals to 3. Okay, so from this graph, actually we have completed the graph. Okay, we can actually label this graph as a y equals to fx, because the fx is fulfilled, the domain, everything is given by the question. Now, to get the domain of the f, I'm going to find the point which is closest to the left. Okay, this is the point which is closest to the left. I highlight it with the green circle. So what is the value of x that belongs to this point? That is negative 1. Okay, so our domain will start from negative 1. And I'm using the close bracket for negative 1 because I see the then circle here means that it includes the point negative 1. And to get the end point of my domain, okay, I will try to find a point which is closest to the right. This is the point closest to the right, and its corresponding x value is 3. So my domain will become negative 1 to 3 and close it with a close bracket. And this interval also can be written in the set form, which it can be written in this form. I have this. Okay, so both are accepted. You can either write your answer in the interval or in the set form. To get the range, I will focus on the lowest point of the graph. This is the lowest point of the graph, and its corresponding value of y will be 0. Okay, this point having the y coordinate 0. So the domain will start from 0. Again, using the close bracket because of the dance circle here. And is followed by the highest point of the graph. This is the highest point of the graph. So what is the corresponding value of y for this point? What is the y coordinate for this point? We want to find it. When x equals to 3, substitute into the function y equals to 4. Meaning that at this highest point, it has the y value 4. So our range will be up to 4 and close it with the close bracket. Also, this interval can be written in the form of a set, which is you can write in this way. Y is greater or equals to 0, less than or equals to 4. Close it with the set bracket. All right. For this example, I'm going to sketch from my basic graph, y equals to x, and followed by y equals to 2x. Which I see the gradient over here is to 2x, meaning that compared to the graph of y equals to x, it will be steeper. And followed by the y equals to negative 2x. When the 2x become negative 2x, you know the graph will be reflected about the x-axis. After that, I consider the negative 1 over 5, meaning that your graph of a y equals to negative 2x will be moved down for 1 over 5 unit. Okay, so this graph will become negative 2x minus 1 over 5. Then finally, I will consider the domain. Again, all right, start from the y equals to x. This is a graph y equals to x. And followed by y equals to 2x. The graph of y equals to 2x, okay, because of the gradient is higher than this basic graph. So the graph will be steeper, yeah, compared to the basic graph. Okay, so it will be like this. We erase this off. Then now I'm going to find y equals to negative 2x. Y equals to negative 2x, meaning that your graph of y equals to 2x will be reflected about the x-axis. So this point will become like here, and this point will become above the x-axis. So the graph will become like this. When you reflect, it will become like this. All right, then delete this. You have y equals to negative 2x. Now, negative 2x going down for 1 over 5 unit, you can see that I'm drawing a line which is parallel to the y equals to negative 2x, but it just the graph is translate 1 over 5 unit downwards. Then now you can just label it as a negative 2x minus 1 over 5, and the green line you can just erase off. Then this y-intercept you can label it as a negative 1 over 5. If you would like to know this point, you always can know this point by substituting y equals to 0. Putting the y equals to 0, you will have your x equals to negative 1 over 10. So here will be negative 1 over 10. Now, after we have done our graph, you need to consider the domain that is given. This is your domain, negative 1 to 1. From this graph, I'm going to find out where is my negative 1. Maybe negative 1. Okay, we're just doing our estimation. Maybe negative 1 will be further a bit to the left. So I put my negative 1 here, over here. And using the dance circle to cut my graph, because I see that the symbol using here is greater or equal, is include the negative 1. So I use my dance circle to cut my graph. And after that, until 1. So from 1 over here, I project a dash line to my graph. And again, use my dance circle to cut the graph. Since the graph want to remain the x from a negative 1 to 1, so we want to remain this part of the graph. Other than that, we want to delete it. So I just want this part of the graph, which I redraw by using the red line and the dance circle. Also, I will change the color. The rest of the graph, I will just, this is the SS1, I will try to delete it. Okay, so this is a graph that we want, and we lack of the value of y. Corresponding value of y we need to find out also. We need to find when the x equals to negative 1 and 1, what is the corresponding value of y? Yeah, negative 1 and 1. So find out the value of y. So here is what I got. When x equals to negative 1, the y equals to 9 over 5. And when x equals to 1, the y is a negative 11 over 5. Okay, so you can now you can label this graph as a y equals to fx. You have done the graph. From the graph, I want to determine the domain. To get your domain, find the point which is closest to the left. The point closest to the left is this point, and it has the value x of negative 1. So we start from a negative 1. Our domain will start from negative 1 and using the close bracket because I see the dense circle. And it ends up with the point, okay, which is closest to the right. This point closest to the right, but and it has the value of x 1. So our domain is from negative 1 to 1. You may also write your domain in the set form, no problem. Okay, using the example that I showed before. So for the range, we'll find the lowest point of our graph. This is our graph. The lowest point will be this point, and it has the value y negative 11 over 5. So the range will start from negative 11 over 5, and followed by the highest point. This is the highest point of the graph, and it has the value of y 9 over 5. Okay, again, use the close bracket. So this is the domain and the range. For this example, simple example, here start from y equals to x. Here we are going to sketch the graph y equals to x, followed by the y equals to negative x. We're going to reflect about the y-axis, the x-axis. And lastly, we have our graph y equals to negative x minus 1. By moving the y equals to negative x, the graph downwards, move down for 1 unit. So here, start from y equals to x. This is the basic graph that we need to remember. From the y equals to x, I will reflect this graph about the x-axis. I will get this. Reflect about the x-axis, you will have this shape. Okay, so erase this off. Now you want to move down your graph 1 unit downwards. You have this. Okay, I'm using this blue line to represent my negative x minus 1. So the negative x we can erase off. Okay, so this is a graph of y equals to negative x minus 1, where you need to label this important point. This is negative 1. To know this point, okay, you can substitute y equals to 0, where you will have a negative 1 also. After that, we just need to consider the domain as less than or equals to 0. So our graph will be cut at x equals to 0. When the x equals to 0, 0 is over here. I'm going to project one line and then use my dense circle to cut the graph. Why I use dense circle? Because here I see there is a sign include 0. Now, x less than or equals to 0, meaning that we want the left-hand side of the graph. Okay, we got two parts of the graph. Choose the left-hand side because the domain just want the graph which is less than 0. Yeah, less than 0. So we want this side, the left-hand side. So I highlight it with the red line. And the circle also I change to the red color. The excess one, the graph, I will just delete it. Okay, so now put a arrowhead over here to show the graph is going to the left, going to upwards indefinitely. Now we can just label it as a y equals to fx. So this is a complete graph. Now we want to get the domain. The domain will be find the lowest, the point which is closest to the left. This is the point closest to the left. Okay, and since this is going to the left indefinitely, so we use the negative infinity to represent the x value. And the point which is closest to the right, this is a point which is closest to the right. Okay, so the x value of this point is 0. We take the 0 and we put the close bracket because here we can see there is a dense circle. Here is include 0. Okay, to get the range, we find the lowest point. This is the lowest point. Okay, lowest point of the graph. The y value is negative 1, so it starts from negative 1. And the highest point is this point. This is not the end point, but we can see that this point actually is going up indefinitely. So the y value which represent this point will be a positive infinity. So this is our domain and the range. For this function, f(x) equals to x minus 6, we're going to sketch the graph of y equals to x first. And then from the y equals to x, I'm going to move my graph, my basic graph, going down for 6 units to obtain the x minus 6. Okay, so we start from the y equals to x. This is the graph of y equals to x. And then I'll move down this basic graph 6 units downwards to get y equals to x minus 6. Okay, the straight line with the red color, I represent it with the y equals to x minus 6. Then the basic graph can be erased off. Then I need to find the value of x-intercept as well. To get the x-intercept, I substitute the y equals to 0. I will have x equals to 6 when the y equals to 0. So this is your x-intercept. Alright, so this is origin. Now, we want the domain so that the domain is less than x negative 3 over 2. So we will find out where is our negative 3 over 2. Negative 3 over 2 is negative 1.5. Negative 1.5 maybe roughly will be here. Okay, negative 3 over 2. From negative 3 over 2, we project a line to the graph. Then we use an empty circle. This time is an empty circle. Why I use empty circle? Because here is the sign of less than without the equal sign. So it's not include the value of negative 3 over 2. We have to use an empty circle to cut the graph. Since the function they just want the x less than negative 3 over 2, so we just want the left hand side, the left side of the graph, and the right side, all this part will be erased off. So I will lengthen the graph. The one which I highlight with the green color is the graph that we want. I will put an arrowhead over here to show that we want the graph. To show that the graph is going to the left and going downwards, and the excess we will erase it off. Okay, so before this, we need to get the corresponding value of y. When x equals to 3 over 2, we want to get the y. From the function y equals to x minus 6, when the x equals to negative 3 over 2, the y is the negative 3 over 2 minus 6. So finally, we get the y equals to negative 15 over 2. So this value, this is the y value, which is negative 15 over 2. Okay, so when x equals to negative 3 over 2, the y is negative 15 over 2. After this, I want to determine my domain. My domain will be finding the point which is closest to the left. So this is the one I highlight with the blue circle. This is the point that we need to consider. Okay, this point is closest to the left. So what is the value of x that can represent this point? Since the graph is going to the left indefinitely, meaning that the domain will start from a negative infinity. Okay, or you can just interpret that this point is going to the left non-stop. So the x value that can best represent it is a negative infinity. And for the domain, the boundary, the other boundary, we need to find the point which is closest to the right side. Closest to the right side. This is the point which is closest to the right side. All right, and then what is the value of x? The value of x is negative 3 over 2. So the domain will be stopped at a negative 3 over 2. And then we close it with the open bracket. How about the range? The range, we will need to find the lowest point of the graph. This is the lowest point of the graph. And we need to get what is the y value for this point. Because since this graph is going down non-stop, meaning that the y value, we will put it as a negative infinity. Okay, and the highest point is this one. The highest point having the y value is negative 15 over 2, right? So this is the negative 15 over 2. We close it with the open bracket. So this is the domain and the range for this function. For this function, I'm going to sketch the graph of y equals to x first, which is my basic graph, and then followed by y equals to negative x, which I can reflect the graph about the x-axis. And after that, I will sketch the graph of negative x plus 8 by moving my graph of negative x towards positive y-axis for 8 units. Yeah. So firstly, we will start with the y equals to 8. I just said this is a graph representing y equals to x. Then now I want to sketch this graph. Okay, sketch this graph of y equals to negative x by reflecting the y equals to x about the x-axis. And I will obtain, when you have reflect your graph of y equals to x about the x-axis, this is what you get, the blue line. And I can erase this off. After you have a y equals to negative x, now you can proceed by moving your graph going up for 8 units to get negative x plus 8. Alright, so this is the green line that representing y equals to negative x plus 8, and I erase the blue line. So because we move up our graph up for 8 units, so this will be positive 8. And this value, we can obtain it by substitute y equals to 0. You will get it as 8 as well. Okay. So now the domain of the question of the function is x less than or equals to 0, meaning that now our graph will be cut at the x equals to 0. I'm using the dense circle to cut the graph into 2 parts. All right, and then since the question asking for the x less than 0, so we are remaining the left hand side, the part with the left hand side, and the right hand side we will delete. Okay, so the one with I highlight with the red line is the one I want to remain there. Okay, so this is using the dense circle, and here I can put the arrowhead to show that the graph is going to the left and going up non-stop, and the excess I will delete it. Okay, so this is the graph that we want, and now I'm going to find the domain and the range by this graph, by looking at this graph. To get the domain, okay, the domain, look at the point which is closest to the left. This is the one. What is the value of x? This point, for this point, the best represent the value of x for this point is the negative infinity. Okay, and then the point which is closest to the right is this one. And what is the value of x for this point? It's 0. Okay, the x value will be 0. So the domain will from negative infinity to 0. And we are using the close bracket to represent the to close the 0, because here we can see the dense circle. For the range, we are looking for the graph which is the point which is lowest at the graph. This is the point, okay, which is lowest at the graph, which the y value for this point is 8. So the range will start from the 8, and I use a close bracket because I see the dense circle here. And the highest point for the graph is this one. Since this the graph is going up non-stop, is going up because the arrow shows that it's going up, meaning that we can use the infinity to represent the y value. Okay, so this is a positive infinity. All right, so this is our domain and the range for the function negative x plus 8, where the domain is restricted to x less than or equals to 0. Okay, this is the last example in my video. Okay, we have a given fx equals to negative 4 over 3 x plus 3. So I decided to sketch the y equals to x first. Again, I start from my basic graph and then sketch the graph of 4 over 3x, which the gradient will be a little bit steeper compared to y equals to x. And then I will reflect the graph of 4 over 3x into negative 4 over 3 and reflect the graph of the about the x-axis. After that, I will sketch the graph of negative 4 over 3x plus 3 by moving this graph up for 3 units. Okay, so start from the y equals to x. This represents y equals to x. After that, I want to sketch the y equals to 4 over 3. 4 over 3 is the value which is greater than 1, right? So the gradient is a little bit more than the gradient of the basic graph. So when we sketch, we can sketch a graph which is a little bit steeper compared to the y equals to. This is a y equals to 4 over 3x. Then the green line I will erase off. After that, I need to reflect the graph of the y equals to 4 over 3x about the x-axis to form negative 4 over 3x. So after the reflection, we will get y equals to negative 4 over 3x. Yeah? After the reflection, we got the red line and the blue line. I can erase it off. After that, I will move the graph of negative 4 over 3x upwards for 3 units in order to form this function, the graph of this function. All right, this is representing negative 4 over 3x plus 3. And from the 0, 0 is going up for 3 units. Here will be 3. So this red line will be erased. Okay, after that, we are interested on the x-intercept. We can substitute the y equals to 0 to get the x. Alright, the x-intercept here will be 9 over 4. After we substitute y equals to 0, we got a x equals to 9 over 4. And now we can consider the domain that the question asked for. The domain just want the x greater or equals to 0. So at the 0 here, I'm going to highlight it, the 0. I'm going to cut my graph into 2 parts. That is at the, it will cut at the 0. Okay, and then since the graph, the function, they want the x greater than 0, so I will remain the right hand side, and the left hand side will be erased. So the part that I highlight with the red line, I will remain, and then the one with the blue, I will erase or delete. And here I can put a arrowhead to show that the graph is going to the left, to the right, and going down indefinitely. And you can label this as your y equals to fx. Yeah. Okay. After that, from the graph, I want to determine the domain and the range. The domain, again, I will find the point from the graph which is closest to the left. This is the point which is closest to the left. Okay, and it has the value of x that is 0. So my domain will start from 0, and I use a close bracket since this point having the dense circle. Okay, and then the point which is closest to the right is this one. Okay, since this is an arrowhead, that means that the graph is going to the right non-stop. So the endpoint for this domain will be positive infinity. And the range, I will find the point which is the lowest point for the graph. Okay, the lowest point for the graph is this point. And again, I see the arrowhead here, meaning that the range will start from negative infinity. We are actually seeking for the value of y for this point. So the value for the y for this point is negative infinity because the arrow shows that it's going down non-stop. And then the highest point of the graph is this one, and the y value is 3. All right, because to find the range, we are searching for the y value. The highest point for the graph is this point, and the y value is 3. So this is from negative infinity to 3, and I'll put a close bracket to show that this is include 3. Okay, so this is our domain and the range. Okay, thank you for watching. In my next video, I'm going to discuss the sketching the quadratic graph, quadratic function. Okay, and determine the domain and the range for the quadratic function by looking at the graph. Thank you.